In this video, I'm going to talk about the concave mirror special cases. In case 1, I have my object that's infinitely far away. And here, the light rays from infinitely far away come parallel to the primary axis, and they reflect from the focus, like this. So the image formed is where these reflecting lines coincide, and it's a single point at the focus. The object beyond C means that the center here is located, the object is located beyond the center here. And when I send my special rays, I send one parallel to the primary axis, it reflects from the focus. And I send my other one, you could have sent it from the vertex, it wouldn't really matter. As long as I used 2 or possibly 3 special rays, I can find where my image forms. So I sent mine from the focus, and it reflected parallel to the primary axis. These 2 reflecting lines coincided at this point. So I draw my image, and it is between the center and the focus. It's real because this is the side where the object is. Here I form my real images, and here I form my virtual images. It's also upside down, meaning it's not upright like my object was. And here I have another rule, so I'm going to write this down here. A virtual image is always upright, and a real image is always upside down. Here I have my real image, and here it's upside down. Okay, so this is vertical inversion, but what does lateral inversion mean? Because this is an arrow, I can't see this here. I'm going to give another example. So this is the number 1. If I laterally invert this, it's going to look like this. Okay, so this image here is also laterally inverted. It's reduced in size, so it's smaller. So that was case 2. Now case 3 is the object at the center. I send my special rays as I did always. Send one parallel to the primary axis, reflects from the focus. Send the other one to the vertex, it reflects with the same angle. Like this. Okay, so the image forms at the center. It's a real image because it's on the side where the object actually stood. It's vertically and laterally inverted because the real object is always upside down. And it's the same size as the object. So if it stands at C, it will also stand at C, just only the upside down version of the actual object. Case 4 shows my object between the center and the focus. I'm going to send my special rays as I do. Send one parallel to the primary axis, it reflects from the focus. And then send the other one to the vertex, it reflects with the same angle here. So these lines coincide here at this point that is beyond C. It's real because it's upside down and it's on the same side. It's vertically and laterally inverted, and it is larger in size. So these were my 4 special cases for a concave mirror. Case 4 is the opposite of case 2. Because here it was beyond C, and then the image formed was between C and F. And now I have my object between C and F, and the image formed is beyond C. And the same thing applies to size. Here the image was reduced in size but here it's larger in size. So this case is the opposite of case 2. Here I have the concave mirror special cases 5 and 6. Case 5 is the opposite of case 1, where the object was infinitely far away from the center. Here my object is at F. And then when I send my special rays, when I send it parallel to the primary axis, it comes back from the focus. And then when I send it to the vertex, it reflects with the same angle. And here, these two lines are parallel, so they don't coincide at any point, which means my image will be infinitely far away, and we call this no image. For the concave mirror special case number 6, I have an object between V and F. V is the vertex. And then this is a makeup mirror. So when we use the makeup mirror, we actually use the concave mirror special case 6 because we stand between the focus and the vertex. And then our image is virtual because it's on the other side of the mirror. And then, okay, so to find my image, I send my special rays. I send one parallel to the primary axis. It reflects from the focus. I send one to the vertex. It reflects with the same angle. But these lines, they're divergent. So what should I do then? I draw the rest of this on the other side of the mirror. And these lines coincide here. And then here's how I draw my image. It's virtual. So it's not over here, it's over here. It's upright because all virtual images are upright. It is laterally inverted. It's larger in size. So when we're putting on our makeup, we see our eye bigger than it actually is. And it's behind the mirror. So these are my last ones from the concave mirror special cases.